Hello, Doctor. Today, I, Ziad Jurej, and my colleagues Despina Reza and Samar Jafal will be presenting profiling high-risk clients mortgage data analysis. This study is focused on analyzing client data to improve risk profiling for mortgage lenders by identifying key patterns and correlations with client demographics and financial metrics. We aim to better understand factors that contribute to client being categorized as high risk. Our main objective is to support mortgage lenders in making informed decisions by providing detailed insights into client risk profiles. This involves understanding variable relationships, assessing client risk levels, and formulating a hypothesis for further testing. The analysis was conducted using Megastat, SPSS, and Tableau. In the dataset provided, we have three qualitative variables and three other quantitative variables, and our variable of interest is the risk.
We began our analysis with a descriptive examination of the three quantitative variables, calculating the mean, range, standard deviation, and skewness. This approach provided valuable insights into the data's distribution, variability, and sensor tendencies. These are the results we got using SPSS and Megastat.
Regarding the gender, there is a slight majority of female clients in the dataset, with a fairly balanced gender distribution overall. Now for education category, the majority of clients have at least a bachelor's degree, indicating that the dataset skews towards more educated individuals with relatively fewer high school graduates. As for the location, clients are relatively evenly distributed between the suburbs and cities, with slightly fewer clients residing in towns.
Next, we conducted a descriptive analysis to examine the relationship between the risk variable, our primary focus, and other variables, starting with gender. The analysis revealed that females are more likely to fall into the low risk category, with 61.5% classified as low risk, compared to 63.9% of males. So the hypothesis to be tested is males are more likely to be high risk compared to females. We then analyzed the impact of education level on client risk profiles. Our findings showed that individuals holding a BIBS degree represent the largest share of low-risk clients at 47.9%, whereas clients with some college education constitute the highest proportion of high-risk clients. This led us to formulate a hypothesis. Clients with lower education levels are more likely to be high risk compared to those with higher education levels. Next, we examined the relationship between location and client risk levels. Our analysis indicated that town residents represent the largest proportion of high-risk clients, prompting us to test the hypothesis that town residents are more likely to be high risk compared to those residing in cities or suburbs. We then analyzed income levels and concluded that low-risk clients tend to have a higher average income. This observation led us to hypothesize that clients with lower incomes are more likely to be high risk. Similarly, our analysis of house values revealed that low-risk clients tend to own higher value properties. This finding led us to hypothesize that clients with higher house values are more likely to be low risk. We concluded our analysis with the MTIR, which suggests that low-risk clients generally have a lower average MTIR. The insight led us to hypothesize that clients with a higher MTIR are more likely to be classified as high risk. We then began testing our hypotheses. We started with the first one, that the percentage of males classified as high risk is higher than that of females. This served as our alternative hypothesis, and the results indicated that the percentage of males at risk is higher than that of females. And with a p-value of 0.0046, which is lower than 0.05, we can conclude that the percentage of male employees at risk is higher than that of their counterparts. Next, we tested our second hypothesis, which is that the average house value of low-risk clients is higher than that of high-risk clients. This is the alternative hypothesis. And since the population variance is unknown, a t-test is used instead of a z-test. In Megastat, we selected the t-test with pooled variance and checked for equality of variances. The p-value for this test is 0.8, indicating no significance. So the pooled t-test is appropriate. and the resulting p-value of 0.2 for the t-test shows no significant difference. Next, using SPSS, the results indicated that the Levene's test for equality was not significant also, with a p-value of 0.9. The results of the pooled variance test indicated that the average health of low-risk client is more than that of the high-risk client, with a p-value of 0.2. According to the sample data, we cannot reject the null hypothesis.
Next hypothesis, which is the average MTIR of high-risk clients is higher than that of low-risk clients, which is the claim. Results indicates that the Levene's test for equality was not significant, with p-value equal to 0.111. The results indicate that the average MTIR of high-risk client is more than that of low-risk, with p-value less than 0.001. According to the sample data, we can conclude that the average MTIR of high-risk client is higher than that of the low-risk. Using Megastat, the p-value of the equality test is also not significant. The p-value of 2.2 times 10 minus 20 is significant, confirming the results obtained in SPSS. Moving on to the next hypothesis, which is risk versus gender, we conducted chi-squared, and our claim was gender and risk are related. The chi-squared test of independence was performed between gender and risk. The relation between these variables is significant. The test provided a strong evidence to support the hypothesis that gender and risk are related. The results show that males are more likely to be at risk than females. The hypothesis here is the risk versus education category. The claim education level and risk are related, which is the alternative hypothesis. The chi-square test of independence was performed between education level and risk. The relation between these variables is not significant. With p-value equal to 0.4134, we fail to reject the null hypothesis. The table above provides a cross-tabulation between risk level and educational attainment. The results show that the percentage of clients with a BA/BS degree who are in the low risk category is 47.9 compared to 33.3% for those in the high risk category. Clients with some college education represent 29.2% of the low risk group, while this percentage rises to 38.9% for the high risk group. Among clients with a high school education, 6.3% are low risk compared to 11.1% who are high risk. For clients with graduate level education, MBA, MS, MA, PhD, the proportion remains equal at 16.7% in both low and high risk groups. Thus, the argument that education level directly correlates with high risk is not strongly supported, as there is no significant statistical association between education and risk in this sample. Moving on to the next hypothesis, which is risk versus location. The claim here is location and risk are related. The chi-square test of independence was performed between location and risk. The relation between these variables is significant, with p-value equal to 0.0251. The test provided an evidence to support the hypothesis that location and risk are related. The results show that clients living in towns have a higher likelihood of being high risk compared to those in suburbs and cities, both at 27.8%. Conversely, clients in suburbs and cities are more likely to be low risk, with similar proportion in each group.
Average income of all borrowers more than $5,600. We need to test that the average income is more than $5,600. Null hypothesis, average income is less than or equal to $5,600. Hypothesis 1, average income is greater than $5,600. Using the one sample t-test results from the image, test value $5,600, sample mean $5,748.03, standard deviation 1,726.851, and sample size 132. From the data we analyzed that the mean of income is $5,748.03 $48.83. To test the one-tailed hypothesis 1, we need to look at the one-tailed p-value, which is half the two-tailed p-value of 0.326. The one-tailed p-value is 0.163. Since the one-tailed p-value of 0.163 is greater than the common significance level of 0.05, we don't have enough evidence to reject the null hypothesis. Therefore, based on the information provided, we cannot conclude that the average income of all borrowers is more than $5,600. The data fails to support the claim that the average income is greater than $5,600. Here we are testing that male are more likely to have MCIR compared to female. Results indicate that percentage of male employees that have high MCIR 39/60, which means 65% of male, have MCIR more than 9%, p-value equals 0.001, while female 29/72, which means 40.2% have high MCIR that is more than 9%. We reject null hypothesis and we claim that more than 50% of male have high MCIR. Average income of female is higher than that of male. Hypothesis 0, the mean income for females is less than or equal than the mean income for males. Hypothesis 1, the mean income for females is greater than the mean income for males. Results indicate that the Levene's test for equality of variances was not significant, p-value equals 0.078. The results of the pooled variance test indicate that the average income of female clients is significantly more than that of the males, p-value 0.2405. According to the sample data, we can conclude that the average income of female clients in this sector is less than that of their male counterparts. We made post hoc tests for income depending on location. This data is gotten from the SPSS. We need to test that mean income differs among location categories. Hypothesis 0, the mean incomes are equal across the 3 location categories. Hypothesis 1, at least one of the means is different. Results indicate that the ANOVA test for equality of means was significant. P-value equals 0.000, which is less than the significance level of 0.05. We would reject the null hypothesis at 0. This means there is strong statistical evidence to conclude that at least one of the mean incomes is different across the 3 location categories. We've made chi-square test for gender versus MCIR. We have hypothesis 0, gender and education are not related. Hypothesis 1, gender and education are related. The chi-square test of independence was performed to examine the relation between gender and MCIR. The relation between these variables was significant, p-value equal 0.001. The test provided strong evidence to support the hypothesis that gender and MCIR are related. Here we did the regression analysis, model summary, coefficients, ANOVA. Gender, location, house value, education, and income explain 38.7% of the variability in MCIR. The R-squared, which means the coefficient of determination, is 0.6622, indicating the model explains 62.2% of the variance in the dependent variable. The F statistic is 15.894 with a corresponding p-value of 0.000. This means that the overall regression model is statistically significant at a very high level. Most of the predictors are statistically significant at the 0.05 level, except for education, which has a significance level of 0.032. All the 5 independent variables are significant according to the table. Based on the analysis of the tables, it can be concluded that the regression model is statistically significant. The model explains a substantial portion of the variance in MCIR, and the predictor variables have a significant collective relationship with a dependent variable. The ANOVA table further supports this conclusion, indicating that the model is a good fit and the predictors are jointly significant.
We also conducted an in-depth analysis to further explore the data, aiming to uncover additional insights and gain a deeper understanding of the patterns within the dataset. We analyzed the various variables, focusing particularly on the relationship between the risk variable and other factors to highlight patterns and trends more clearly. We conducted a deeper analysis by comparing the various variables against each other, beyond just their relationship with risk, to identify additional patterns and correlations within the data.
Using SPSS and Megastat, we found out that the dataset shows no high or low outliers for house, income, or MTIR values. We also did a percentile analysis for income, house value, and MTIR.
Alongside the percentile analysis, we also did extreme values analysis for income, house value, and MTIR. And during the descriptive analysis of the quantitative variables, we also did the frequency distribution of the income, the house, and the MTIR.